Okay. Any questions about the homework? Do you think, let me ask this, do you think this will be on Thursday's exam possibly?
Yeah, of course.
Yeah, possibly, right? Because I can't put confidence intervals on Thursdays, this has to be on Tuesdays. So, it could be on both. What do you mean 9 questions? She said there are only gonna be 9 questions.
Wait, how many questions are there now that you made it?
I don't know. But I don't know. She said there's 9.
Minutes, what do you mean?
That's what you told us last time. He said around 9.
Is that what I said?
Yes. He said around.
Around,
9.
I thought I said between 2 numbers.
You said 9,
Is that what I said, 8 and 10?
Yes,
Yeah, that's what I said, 8 and 10.
So what's happening to the whole semester?
It's 10.
Well, no, not, yeah, how can you? That's a good question. She said, how can you include the information we learned all semester in just 8 to 10 questions? And that's what, we have 2 parts, so don't forget, there's gonna be another 10 to 12 questions on the second part. Does that sound right? Did I say that last time?
Yeah.
10 to 12 on the second part. So now the question is, how can you quiz this on the whole semester on, what is that, 18, 19, 20 questions only? That's why you should go ahead and make the assumption. By the way, today, I have a small list of things not to study that we'll talk about before the semester's over. But that's why you should make the assumption that most likely the most important subjects we learn this semester will most likely be on the final. You should go with that assumption. What was the most important things we learned this semester? Because that's really what I want to highlight in the final exam are the most important subjects. Not necessarily the small things that we learn, the big things we learn. Like I said last week, I said, do you think exponential will be on one of the 2 finals? Obviously. Do you think Poisson will be on one of the 2 finals? I mean, that's crazy to not think it will be on there. The only thing you got to worry about is, will you be solving them manually or using Excel? You know, be prepared for both. It could be. Well, not in one question. If I were to ask you to solve it manually in Excel, it'd be 2 separate questions. Because there'll be so many people that are reading so fast, it's hard enough to get everybody to realize when to do it manually in Excel. It's like you guys skim over the question and you skip whether you should be using Excel or manually sometimes. And so if I put a question that says solve both manually and Excel, there'll be so many people that only do it one way and not the other because they just misread it, that I don't want to take that risk. But if you do have to solve both, it'd be 2 separate questions. And then there's the multiple choice. Now that's the hardest part to predict. That's the hardest part to predict what would be in the final because, you know, yes, the multiple choice, I do select multiple choices that are hitting the most important subjects for the most part, but some of them are just, hey, I want to challenge you a little bit. That's what some of the multiple choice are, but they're not as the easiest questions. If a multiple choice only worth a 0.5 point, then I must have thought it was the easiest question on the whole quiz, and you probably have one of those. Does that make sense? So don't read too much into it. Whatever the obvious answer is, it's probably the obvious answer, because look, it's only 0.5 point. And if there's a multiple choice question worth a whole point, I probably thought it was a harder one, and that maybe you need to focus on it a little more and read a little more into it possibly. Gosh, I'm giving away all the hints about my test. Man, you guys should ace this. Walk out of here with A's. There's enough people that fell off the planet of the earth to offset you, so it'll be fun. You got that one? All right, you guys, what are we talking about? Let's get to the new stuff. Hang on a minute. Let me figure this out. Confidence intervals. I know, hopefully you're writing down most of the stuff you see on the board because this is all the really important stuff, especially what confidence intervals really do. Here's the definition. Range of values that, with a certain level of confidence, contains the population being in proportion. Now, here's what that means. All semester, we have been doing these calculations because we've been given what the population information is. What's the population mean? What's the population standard deviation? What's the population proportion? Given the population proportion. In 302, it's all about now you're going towards where you won't know the population information. That you got to just use the information you get from the sample and do calculations based on the sample information. As a tradition towards this spot, confidence interval is one of those transitions, meaning what confidence interval does, it takes the sample information and calculates a range of numbers, kind of like an upper lower control limit, almost just like it, but this range of numbers and that are defining where most likely, with a certain amount of confidence, the population number exists. That's all it's doing. It's saying, look, we don't know the population mean. The population mean is somewhere in here, but we've just calculated based on the sample some confidence intervals, and we feel confident the population mean is somewhere between them. That's what these upper and lower confidence intervals mean. They're where does the population mean land? Now, there's different kinds of confidence. If it's really important that you know where that population mean or proportion is going to land, you're going to use a big confidence interval, like 99%, meaning I have 99% confidence that the population number is somewhere between the intervals I just calculated from the sample. If something's not quite as important, that you just want to get close to, you want to be kind of like, hey, I know it's in here, and I have 90% confidence that it's between two numbers, the numbers are going to be a little tighter. They're going to be a little tighter because you're walking in with only 90% confidence, meaning there's 10% confidence the population may not be in between these two numbers. So that's what's going on here. How do you determine what kind of confidence intervals you're going to form based on the sample? I want to go back to that admissions, where we're the admissions director. We got 900 applications we've accepted. We haven't numbered them all or put them all in the system yet, but we have them numbered. If we took a sample from there, we could form confidence intervals from the sample and then go to that meeting and say, we have 90 or 95 or 99 or whatever percent we choose, confidence that the population number for all of those applications is in between this range. Instead, we walked in there and saying, hey, we found a sample number, and we know it's somewhere near that sample number. We never gave a range. We just said we know it's somewhere near the sample number. It was something like, whatever it was. Go ahead, what was the question, Christine?
Oh, I just want to know what the word next to confidence is in the equation.
Intervals, did I spell it wrong?
No, that
middle?
equation, like the Excel equation.
Confidence, did I spell it wrong?
No, the Excel equation.
Mean plus confidence.
The
Where
mean
am I?
plus confidence.
Oh, right here?
Yeah.
That in the word?
Yeah.
Significance. Significance equals opposite of confidence. Significance is what alpha is in the Excel formula. Let me repeat that. Good question. This is the difference today compared to the homework you just did. This is really the hardest part of
Standard
today's lecture.
deviation.
Is
Standard deviation.
what is that number? It's called the significance, which is the opposite of the confidence, which is also called alpha. And let me make sure you understand where the alpha comes from. When you have Excel open, hang on a minute, let me get here. And you type equals 12 plus, and then you start using the word confidence. There it is. I'm going to double click on the word confidence. Look at what it says for the first number. It says alpha. Well, alpha is really the significance, which is the opposite of the confidence. The problem's going to give you the confidence. You got to know to use the opposite. Hang on, you ready? This is the most important part. Some people find this hard, but I'm going to make it easy. If the problem said, hey, I want you to form 90% confidence intervals, the opposite of 90% goes right there. And that would be 0.10, 10%, the opposite of 90. If the problem says, I want you to form 95% confidence intervals, and you're going to use Excel to find that confidence interval, the number that goes right there, anybody get me? Tell me what goes there.
0.05.
So exactly, 0.055%, the opposite of 95%.
How did you get that?
Oh,
What's the opposite of 95? Take 100% minus 95. What's the opposite of 90? 100% minus 90 is 10. The opposite of 99%. You're supposed to form 99% confidence intervals. You're using Excel. That first number will be 0.1. 0.1. 1%. The opposite. That's how easy it is. You're done. Go home. Good to see you. Am I recording this? Just a second. Did you get it? That's how easy it is.
Yeah.
Don't let it fool you.
no, it's not recording.
It's not recording? No, it's not April Fool's.
No, it's not recording.
Seriously? All that time? Oh, you're gonna be joking. Tell me you're joking. Yeah, you're joking.
No, I'm,
Look at it. It's moving. Look at the time.
Why is the circle not
why
as
the
wide?
circle is not like, that big one is supposed to be like,
Oh, really?
yeah, inward, I don't know.
Well, I don't know. Time's
Probably
moving.
Maybe
I'm not
because
gonna
it's
touch it.
older.
That circle's to stop it. And I'm gonna edit all this conversation. That's what I wanna know. You'll have commercials, it'll be the first one you have commercials, I gotta edit. Yeah, it's recording.
Oh, what?
Yeah, it is. It's recording. So all that's on record.
April Fool.
Good news is I could just post last semester's.
No, we want to.
Okay, so now, let me go through that definition again. Where am I? I'm right here. Where's slide 5? Oh, I passed it. It says a confidence interval, let me do it again. Confidence interval or interval estimate provides a range of values that, with certain level of confidence, contains the population parameter. That's what a confidence interval is. And that's where it says right there, certain level of confidence, that's the confidence being given to you in the problem. It's gonna say with 90% confidence, with 95% confidence, with 99% confidence. Whatever the confidence is being given to you, that's how much confidence you're gonna have in the results. Okay, I wanna make sure you understand what about today something. Right here is the manual equation to solve for the confidence interval of a mean. And you'd be given a standard deviation. It's the mean plus and minus, so you're doing it twice. Z is based on how much confidence you're being told to have, times the standard deviation over the square root of the sample. This is the standard error of the mean. We're very familiar with this. Let me say it again. Standard deviation over the square root of the sample, which we're familiar with. Now, this is not a 3 like last week's homework. This Z is based on how much confidence is. Gets added and subtracted to the mean. There's the difference, is that Z. Now, here's the good news. This manual equation for a mean with standard deviation and this manual equation for the proportion to find the confidence intervals will not be on your final exam whatsoever. Today is all about you solving it using Excel. This one is for Excel, if you're given a mean and a standard deviation to find the confidence interval. This one's using Excel, if you're given a proportion to solve for the confidence interval. I have a blue star there and there. These are the two things you focus on for the final exam. Those manual ones, I would need you to understand how it's done, but it's not necessary for the final exam.
For both parts?
For both of them, for both parts of the final exam. The manual one is part of today's lesson, but you're not gonna be tested on it. The Excel one is what you're being tested on. So let me highlight this for the mean with the standard deviation one. The Excel portion of that to solve it would be the mean that's given to you, plus and minus, so there's two equations just like last week's homework. Confidence, the same word as we used in last week's homework. Parentheses, that first number is called the significance, or alpha, which is the opposite of the confidence. So if the problem says 90% confidence, that would be 0.10. If it says 99, 0.01, you get it? Comma, standard deviation, comma, sample size. It's that easy. Let's go to proportion now. We're going to talk about it manually. The difference between this week and last week is that Z was a 3. With quality control, we're using 3 standard errors. But with confidence interval, that Z is whatever the amount of confidence that the problem says. It changes all the time. So we're not using a 3 in either one of these manuals. And you won't have, I mean, there's homework, but you don't have to do the homework. You don't have to do these manually for any reason whatsoever. They're not on the final. But the homework has them. And we might set one up if we have enough time today, just so we know how to set these up. Go ahead.
So for this, you're just gonna put, if you gave us, you're just gonna put 0.9B for the manual? And then
No, this Z is a whole big deal. It's not that easy, but you're not gonna be tested on it. But I am gonna show you how to find the Z.
But for the Excel, it's the opposite.
Excel is always whatever the opposite of the confidence is in the problem. Always that first number, the opposite. Okay? Now, here's the standard error of the proportion, if you recall. The given proportion times 1 minus the given proportion divided by the sample size, whole thing square rooted. The whole thing, not just the numerator, not just the sample size, this whole thing is square rooted.
But the whole square root is the standard error, right?
The whole square root's the standard error of the proportion, yes. But in Excel, you leave the sample size out for that second number, just like you did in the homework you just handed in. Square root, parentheses, given proportion, asterisk, parenthesis, 1 minus given proportion, parenthesis, parenthesis. No sample size. Just like last week's homework. Nothing's changed. Sample size is the last number. Yes, there is SQRT there though. Is everybody still with me? So far? Yes.
Does that stand for population in the top?
Well, where are we talking about? Here or here?
There, where your
On the
left hand
left
is. Left hand.
That's not the first one. POP? No, right there.
Population? Yeah, these are, I'm gonna talk about these in a minute. This right here?
Population?
Yeah. Okay, so, here, I'm talking about right now, now that I think about it. There are 3 formulas in 302 we are gonna go over in detail on how to find confidence intervals. And in 302, you gotta determine which formula to use based on the information. If you're reading a problem that tells you the population standard deviation, that says, and this population standard deviation is, then you know to use Z calculation. This is Z calculation right here. That's a Z calculation. If the population standard deviation is not given to you, instead it says the sample standard deviation is. It's not telling you the population, it's telling you the sample. In 302, it's a different formula using T, which we have not learned in this class. So no, we're not learning it today, and no, it will not be on your final, and just forget about this one right here, because we're learning it in 302. The third one is proportions. It has nothing to do with the mean. And all proportion questions use Z, which is this formula right there.
First and third?
So we're using Z no matter what. There's no reason for you to even determine what kind of problem you have, because you know if you're using Z. All you have to determine is, does this problem have proportions, or does this problem have a mean and standard deviation? Which one am I using? But it's easy. I mean, if it has standard deviation, you know to use this one. If it has proportion, you know, and no standard deviation, you know to use that one. Yes.
Are we gonna need those for the exam?
Are you gonna need this? No.
No?
Not for the final exam?
Yeah.
Not at all. We are always gonna be using Z. We're not gonna use T in this class. We're not going that
But
far.
even Z won't be on the exam.
I'm sorry?
But even Z won't be on the exam.
Oh, Z's on the exam, what do you mean? Oh, not manually, no. You're using this. This is called using Z. Yeah, it will
But
be.
not necessarily.
Can you solve it like?
Yeah, we're gonna solve a couple. All right, let me see. I want to look at the board, make sure I talked about everything. Blah, 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 blah. By the way, what you have here, and I'm gonna go over a couple, is what if the problem says, solve it manually, which it won't on the final exam. If it did, and it said it was a 90% confidence, I'm giving you what that Z is right there. If it's 90%, it's 1.645. 1.645. If the problem says it's 95%, it's 1.96. That is 1.96. That's 1.96, depending on what kind of problem you have. And if it's a 99% confidence, the Z is 2.576. How did I get those numbers? You ready? Here's how you get them. Whoop, again. Right there. You ready? Let me show you. Let's start with this one right here. No, 95%. 95%. If I said the area under the bell curve in the center is 95%, what area would be in the tails added together? What's left over? 5%. But there's half of it's in one tail, half of it's in the other tail. So to look it up on your Z chart, which is what the Z would be out here where the opposite of 90%, 95% would be, you have to split the 5% in half. 2.5%. And you look for 2.5% on your Z chart. And you say, what Z would land at 2.5%? What's the decimal for 2.5%? 0.025, right? So I'm gonna get as close as I can to 0.025. Okay, where's my pointer? Right there. 0.09, 0.01, 0.021, 0.026. There it is. Look at my pointer. 0.025. And look at what the Z is. I'm going all the way over. 1.9, ignore the negative. 1.9, and now go up 6. That's how this Z, 1.96, gets determined what to use here in these manual equations. You have to take the confidence, figure out the opposite of the confidence, split it in half, look it up. Let's do another. You ready? 90% confidence. What's the opposite? 10%. Split it in half, 5%. Look up 5%. Now, 5% is not on here exactly. I think the closest you can get is 0.04, where is it? 0.0495 right there and 0.0505 right there. So right between these two. So if you look, 1.6, and then this is 4, and this is a 5. So, where are they? Where's both of them again? I lost them. They're there. One's a 5, one's a 4, one's a 5. There it is. So, 1.6, they're right between the 4 and 5, so 1.645. Right between them. That's where that number comes from. Does everybody get it? That was the hardest part of today's lecture too. Figuring out what Z to use here based on what you're reading the problem, which is the confidence level. All right, so I'm going to get an example. Go ahead. I'm sorry.
I understand this plan is when you go 5%, but when you look for it, how do you find 1.0?
Okay, look for 5%, which is 0.05. This one, the closest you can get is 0.0505, and this is 0.0495. Notice this one is like 0.005 less than 0.05, and this one's 0.005 more than 0.05. So what would be, so you go all the way to the left, you see 1.6, and then you go straight up, 1.64 or 1.65. What would you use, 1.64 or 1.65? Instead, 1.645, right between the two. I found the mean right between them. What would be a number if there was a number between them? Or you could just use 1.65. How's that if you want to round? But kind of. Because you got to estimate where would 5% be based on this, because this is all just estimated. Just the manual. That's why you don't need this for the exam. Let me repeat that. Looking up what Z to use is only for the manual equation, so it won't be on the exam. The part that's on the exam is all about what will that first number be, what will that second number be, what will that third number be. And they're pretty easy once you realize the first number is the opposite of that. So let me go to an example here. Let me see, where's my first example? I'm going to go to slide 10. Okay, a sample of 25 cereal boxes yields a mean of 1.02 pounds of cereal per box. Construct a 95% confidence interval for the mean of all the boxes in the population. Assume that the weight is normally distributed with a standard deviation of 0.03. So here we go. How do we come up with this 1.96? 95% confidence. The opposite of 95% would be 5%. 5% split in half would be 2.5%. If we looked up 2.5% on the Z chart, we would get 1.96. Now let me tell you something. You don't have to look these up on the Z chart. They're all over the internet. Every one of these percentages with their corresponding Z are all over the internet. And on your, where are they? Is that one? I can't remember what slide, but they're right on here, 13. Slide 13 has them right there also. 95% would be 5%, divided in half would be 2.5%, 1.96. 90% would be 10%, split in half, 1.645. So they're literally giving you the Z's right there. And these are the most common confidence interval percentages. 95, 90, 99. So you're given the Z's. You don't have to go to the Z chart and look them up. And when I talk about this, I'm talking about for 302, because you will definitely do this again in 302. More intensely you're doing it here. And here you only got to get this confidence interval using Excel. But you're heading to where you have to do it manually. You're probably in your first week, no matter who you have, for 302. All right, so now let's go back to the problem. 25 cereal boxes is in our sample size. The mean is supposed to be 102. We're saying, hey, what is it? 102 pounds, all right? We know there's maybe supposed to be 1 pound in there, but the sample had 1.02 pounds. We're going to use a 95% confidence interval calculation. And by the way, I almost forgot to tell you, this part that's to the right of the plus and minus is called the standard, it's called the margin of error. Let me repeat that. The part of the calculation manually that's to the right of the plus and minus for both of these, proportions or mean, the part to the right is called the margin of error. You're gonna hear margin of error all the time. What they do is they take a sample, they found the mean, they calculate the confidence interval. At 95% confidence, this is the margin of error. Does everybody see the margin of error here? I wanna make sure you see it on this slide. What is it? What is the calculated margin of error? No, not 0.03. That's the standard deviation.
1.96.
Say it again.
1.96.
No, not 1.96. That's the Z. Put it all together. The margin of error is
0.012.
there it is, 0.012. That's the margin of error. So you'll hear on the news, hey, we believe from our sample of 25 that the population mean is somewhere between 1.008 and 1.032 with a margin of error of 0.012. That margin of error is that calculation on the right that they added and subtracted from the sample mean. When you hear the word margin of error, it's that right part of the calculation. So anyway, there's how it's done manually. Now, this is your final exam question. You're supposed to give me and solve it using Excel. So let's get it set up. Am I using the right-hand equation for Excel or this left-hand equation? Which one? Which one? Okay, hang on a minute. The mean is 102, the standard deviation is 0.03. Because this is the only one that uses standard deviation, this one's using proportions. So this one's using standard deviation. Here we go. Equals, what's the mean we found? 1.02, 1.02 plus, and then we do it again with a minus, right? There's two equations going on here. Parenthesis, 25, 0.05? What's the first number? What's our significance? What's our alpha? Point what?
0.05.
0.05. Very good. The opposite of 95% in a decimal form would be 5%, 0.05, comma. Standard deviation, given, 0.03, comma. Sample size, given, 25, parentheses. We're done. And now we get the result. Let's see how close we are to the result there. What's the result here for the upper? 1.032. Remember that number? Let's see if we get the same one. 1.032 equals confidence. Oh, I started one. What is this? 1.02. 1.02. There we go. Alpha, we said is 0.05, 0.05, comma, 0.03, 0.03, comma, 25, parenthesis, and we should get, I forgot already, 1.032. Here we go. 1.03176. Rounded would be 1.032.
You don't have to put
Everybody see what I did? To get that? This
I
is
got it
almost too
already.
easy now.
Thanks.
Go
Are
ahead.
you supposed to read confidence?
Use the word confidence.
Address.
Oh, I'm sorry.
We're going
Hang on, I
to-
forgot to put the word confidence here.
first up.
Thanks.
Or all of them.
Probably the main ingredient. Thank you.
Can
Confidence.
Question, please?
Huh?
Can you go back to the question?
Go back to the question, yes.
So is that the way that was being written?
Those would be the way it's written right there. A sample of 25 cereal box. Hey, you know what? Let's go into a problem. Let's do one.
Next week.
Here you go. You can see how it's written. Let me make it bigger. Average life expectancy of Bostonians is 78.1 years, according to the Boston Globe. Assume that the average was based on a sample of 15 Boston people, and the population standard deviation is 4.5 years. Give an Excel equation result with 90% confidence, the interval of the population average life expectancy. All right, help me set this up. Hang on a minute. Let me erase this. Are we using, well, we're using this one because this is the one we're learning. So here we go. Equals, what's the average age of Bostonians?
78.1.
78.1 plus, and then there's also a minus going on, confidence. Hang on. I thought you were doing something to the camera. Confidence, parenthesis. What? 0.1, what do you mean 0.1? Is this 90% confidence?
Yeah.
So 0.10, comma, what's standard deviation?
4.5.
4.5.
It is 4.5, very good. 4.5, comma, what's the sample size?
50.
50. Parentheses, there it is. It's that easy, go ahead. Alan?
Go ahead.
So when will we know not to include the sample size within the equation?
You don't, what do you mean not to include sample size? Sample size is always at the last number, no matter which equation you're using.
Well, no, Christina was trying to ask.
What are you saying, that you wouldn't use sample size? I think what she's trying to say is, don't include the sample size as the second number here. You gotta, it's the whole thing, square root the top, leave the sample size off and put it comma sample size on the end. Is that what you meant?
So we're basically using the sample size for like all the equations, right? The Excel ones.
Yeah, sample size is used on all the equations, is that what you said? Yes, it's the last number on all the Excel equations for sure.
Appreciate it.
All right, let's do, now, we got this one, we don't need to find an answer. It's all about, most of the points are right there in the setup, right? All right, now, let's look at this equation, right here. Or wait, before I do that, let's talk about this manually, this equation we just read. Go ahead.
What was the margin of error exactly?
The margin of error is the whole calculation to the right of the plus or minus sign. So in this case, it would be whatever z is, which I was about to bring up, times what's the standard deviation here? 4.5 over the square root of 50, and then whatever that z is. Let's talk about this z. All right? We knew to put 0.10, 10% here, because that's the opposite of 90%. But if we were solving this manually, what would be the z there? This is still 4.5, this is the square root of 50, but what's that z right there? Anybody?
For the 90, 1.645.
There you go. Very good. That's the z. If we were to take 90%, the given purport or the given confidence, find the opposite, which is 10%, split the 10% in half, which is 5%, look up 5% on the z chart, this is what we get, 1.645. And that's what would be that z right there, manually calculated, 1.645. And now, everything to the right of this plus, 1.645 times this, that's the margin of error. Everything to the right of the plus or the minus sign.
Can we see an example with the other equation?
But yeah, you mean with the
Proportion.
proportion now. You ready? The example I was going to do proportion, I'm going to skip that example and do the example from the homework instead. So let's do this one. Is this one right here? Let's look. No. Is this one? Yes. Here we go. This is a proportion. It says a survey of 1,026 people asked, what would you do with an unexpected tax refund? 47% responded that they would pay off debt. Give the Excel equation result to find a 95% confidence interval for the population proportion of people that would pay off debts with an unexpected tax refund. Here it is, our sample, we have a sample of, how many again? 47%, how many is in the sample? 1,026, that's a big sample. I'm gonna set it up using Excel. This is just like a final exam question. And you would use Excel to solve it. Are you ready? Equals, what's the given proportion?
0.47.
0.047, that's right, 0.47, you're right. Plus the word n minus down here below, confidence, here we go now. Parentheses,
0.05.
how do you know it's
Because
0.05?
it's not opposite of 95.
That's right, the opposite 95% confidence would be 0.05, very good, comma. Here we go. SQRT, right? SQRT, parentheses, 0.47, 0.47, what's next? Asterisk, exactly. Parentheses, 1 minus 0.47, parentheses, parentheses, comma.
1,026.
Very good, 1,026.
6.
Wow, 1,026 parentheses. There it is. Just like last week's homework, the only difference is we're using the opposite of the confidence for the first number. That's the difference. Instead of 0.0027 between last week and this week. That's the only difference. Yes, doing this manually would be a little hard right now, but this is not going to be on the exam and it's not on your homework, and you're not even handing in this homework if it is. But let's talk about what this z would be. What would that z be based on? 95% confidence, there you go.
1.96.
1.96 would be that z, and you do the calculation manually. 1.96 times the square root of all that is called the what? 1.96 times the square root of all this would be called, what would this part be called? Margin of error. Margin of error. I got to make that a multiple choice question. You've got to know the margin of error.
What's the question?
Yeah, exactly. That's right.
Anything to the
right.
right of the
Just put a
question.
big star next to the words margin of error. Here we go. Margin of error is everything to the right of the plus for both of these equations. Everything to the right is called margin of error of the plus symbol or the plus minus symbol. Including the z and the whole calculation, that's margin of error. Whatever that calculates out to. Plus. Well, this is if you include this, now you found the confidence interval. This portion is just called the margin of error. Just the part to the right. For both equations, this is margin of error, that's margin of error. All right, so we saw an example of each. I need to go over some definitions here real quick. Going to slide 13, let's see, 13 we talked about them. 13, I just was pointing out that you're given these. By the way, yeah, again, you don't have to solve this manually on the final exam, but if you did, I would not be tricking you. I would be giving you one of those three confidence, so you would have the Z right there on your PowerPoint if I were giving you this kind of problem, but I'm not.
Can we do a extra credit?
No, no extra credit.
Do we even need to know how the equation?
Usually I just need to know it, but only because you need to know what goes in the Excel. It's almost too easy. Here's where it's explaining where we are in 14. The right side being called the margin of error, which is, where is that? Margin of error is the z times the standard deviation over the square root of n. When it comes to the mean, that's part to the right of the plus or minus is the margin of error. Want to point that out. The other thing, okay, here's some things you need to know. What happens if the standard deviation were to increase? In this case, it was 3%, then it goes to 5. The interval itself would increase. Let me repeat that. There's three things you gotta learn what increases the interval. The standard deviation increases the interval. Next, the sample size decreasing increases the interval. Let me repeat these. These are three things that increase the confidence interval size. Makes it wider. Let me repeat them. One is that the standard deviation gets larger. 2 is that the sample size gets smaller. And then 3 is that the confidence interval gets bigger. Is that what this one says? Yeah, like this one's going from 95% confidence to 99. It also makes the interval wider.
What's number 3?
Last one is that the confidence interval gets larger. So if it's going from 90 to 95, or 95 to 99, as that goes up, the confidence interval gets wider. Wow. Okay, here's another example. Going to slide 31. There is the formula for proportions again. Given the proportion of the sample plus and minus the z times the square root of the proportion times 1 minus the proportion over the number of the sample. Everybody has that. You guys have all this. This is just an example. You want to do this one real quick? Here's an example of 25 ultra-green cars. 7 of the cars obtain over 100 miles per gallon.
Yeah.
Construct a 90% confidence interval around this information. Okay, what's the proportion here? This is tricky. This is just like a final exam though, so you better learn this trick right now. No, I don't know, I haven't calculated, but how did you get that number? 7 divided by 100? No.
Anywhere.
Almost. Let me stare at this for a minute. A sample of, oh yeah, you're almost there. You're not 7 divided by 100. Let me repeat the question, ready? A sample of 25 ultra-green cars, 7 of the cars obtained over 100 miles per gallon. Go ahead.
It's 7 divided by 25.
That's it, 7 divided by 25. This is not giving you the proportion. You have to calculate the proportion. It says 7 out of 25.
7 divided by 25.
7 divided by 25 is 0.28. Now you have the proportion, you do it just like right here. Let me go back, let me read it again. 25 ultra green cars, 7 obtained 100 miles per gallon or more, of the over 120 miles per gallon, 100 miles per gallon. Constructed 90% confidence interval. Here we go. I'm going to use this. This is a proportion. Equals the proportion we just calculated. 7 divided by 25 was it 28?
Yes, 0.20.
0.28 plus and minus the word confidence on the confidence. And parentheses. What is the first number here for our 90% confidence interval? 0.10. Very good. Parentheses. Here we
Square
go.
root.
I'm doing it this way. SQRT parentheses 0.28. Asterisk, almost forgot it. Parentheses 1 minus 0.28. Parentheses, comma. How many in the sample? No.
25.
25. There it is. There it is. The only reason this problem was hard is because it didn't throw the proportion at you. You had to say, oh, wait a minute, 7 out of 25 and calculate the proportion.
We have to do that on
You probably are going to have a question on the exam where the proportion's not thrown at you, and you might have to calculate it. Yeah.
What's the perfect?
You read what you wrote.
Well, we read what I wrote, same thing? Yeah. Okay, you ready? 7 divided by 25 is 0.28. So 0.28 plus the word confidence. The opposite of 90% is 10%, so 0.10, parenthesis, comma, SQRT, parenthesis, 0.28. That's supposed to be an 8. That's supposed to be an 8, sorry. There you go. 0.28, asterisk, parenthesis, 1 minus 0.28, parenthesis, comma, 25, parenthesis. That was me.
There's another way that would be like the question, we would have question like this, is it like the other way or?
No, that's it. That's it. Either you're throwing that proportion at you or you're being told like 7 out of 25, something like that. Here's the deal though, on the final exam, binomial distribution problems have how many out of how many also. So that's the tough part about the final. And I mentioned that last week, that we are now getting into problems that almost read like they could be either binomial or normal distribution, something like this confidence interval. This is tough exam. I'm glad I'm not taking it. Good luck to you.
Can you write a hand in the question?
All right, huh?
Can you write a hand in the question?
All right, hang on. PowerPoint slide 18. Let's look at what this says. IQ tests are approximately normally distributed with a standard deviation of 15. A sample of 22 employees gives a sample mean of 106. Compute a, let's do the 99% one this time. Where's my eraser? Are we using the right or the left-hand side equation? The left, we're not even using this one. I didn't mean to get rid of this asterisk here, because this is an important equation we do. We're using this one, so here we go. Equals the mean. What's the given mean?
106.
106. Here we go. 106 plus and minus confidence. Confidence. Parentheses.
It wants 2.
Yeah, we're not doing 90%. We're doing the 99%. So what's this first number?
0.01.
0.01. The opposite of 99% would be 1%. Comma. Standard deviation.
15.
Okay, 15. Sample size.
22.
22 parentheses. That's easy. Again, that first number is the opposite of the confidence. When you're doing confidence intervals, if it's 99% confidence, that's 1% in decimal form. You can put 1 in a percent symbol, it'll still work. 106 plus and minus. So you're really writing this twice. I'm just not writing it twice, that's all. But in reality on the final, you gotta write this twice, one with a plus and a minus, get 2 different results. Gotta do them both. Oh my gosh, this file's too easy. I wish I were here. I think that's all I got. Let me see, how much time we have?
20 minutes.
The what not?
Oh yeah, there's that part. I forgot about that. Okay, and then we have an in-class too.
In class?
We have an in-class, what are you talking about?
Tuesday.
True it is. Tuesday. But it's our very last lecture, and this subject, you guys need to make sure you understand how to do. And this in-class assignment is doing nothing but preparing you for the final exam, trust me. Meanwhile, you have this list, I promise. Let me get it up here.
You do it.
Hang on. No percent
So I need
frequency
Superman?
tables on the final
And
exam.
Superman and you?
Oh, wait, we can't have this
You
on
don't
the
do everything today?
video. Oh, this is only if you showed up.
Do we actually have a necklace?
So it's not stopping. So what's going on that it's not stopping?